All right, y'all. So in 8.3 support, we're going to learn about synthetic division. Okay. And there's three things I'll use synthetic division for. The first thing I can use synthetic division for is to find the quotient and remainder. Okay, sort of like long division. Next, we'll find function values. And then the third thing I can use it for is to determine if a number is a zero. So support will deal with the quotient and remainder. And then in college algebra section for 8.3, we'll use it to find function values and determine if a number is a zero, okay? So what I'm going to do first is give you the steps to doing synthetic division, and then we'll start playing with them examples. So the steps, we're going to be given a polynomial, and they're going to have me dividing it by some other factor. So the first steps that we do, we're going to write the coefficients of the polynomial. And remember, the coefficients are just the numbers, okay? Now, here's the thing. We write these coefficients in descending order. If there's any missing terms in the polynomial, then we have to use a zero for those missing terms. So we use zeros for any missing terms, because we have to have placeholders in that, okay? All right, so we write those coefficients out. Under the coefficients, I'm going to draw a bar. So my little bar, it'll look like a bar, and then we're going to box off the right side of it. Okay. And that little box, you'll learn as we're going through, that little box is where we put the remainder. So we're going to draw a box under the coefficients. Now, here's the thing. Leave space between the coefficients and the bar. Well, y'all, the instructions are longer than these problems will be, okay? All right, so I've got my coefficients. I'm drawing my bar down under it. Next, I got to find C, and C is basically what we're sort of dividing by. So we write our C. Now, here's the thing about C. If the synthetic division is used to find a quotient and remainder, So if I use synthetic division to find a quotient and remainder, then C is opposite in sign than the factor. Okay. If it's used to find function values or zeros, then it keeps the same sign. So if it's used to find function values or zeros, then C keeps the same sign. All right, so I've got my coefficients, got my bar drawn. Over here, I'll put my C. So the first thing we do, we bring the first coefficient down under the bar. So that first coefficient, we're always going to bring down below our bar. Now, the number we brought down under the bar, we're going to multiply by C. So we're going to multiply the number we brought down by C and place into the next column. All right, so I'll bring the first number down. I'm going to multiply by C and put that number in the next column. That's why you had to leave a little space in between them coefficients and our bar, okay? Now, once I've brought that product into the next column, I'm going to add that column together. So add that column and write the answer under the bar. Okay, so now I've got me another answer under the bar. I'm going to repeat the process. I'm going to multiply by C, bring that answer into the next column. So we're going to repeat the process until done. Now, y'all, let me let one in real quick. Now, the numbers under the bar when we're done are the coefficients of the new polynomial. Well, how about this? They're the coefficients of the quotient and the thing about the coefficients of this quotient, it starts 1 degree less than the original polynomial. So it starts 1 degree less than the original polynomial. So that means if I started with an x to the 5th, these quotients would start with an x to the 4th, okay? And then I would just write my quotient out in descending order. The number in the box is the remainder. So the number in the box is the remainder. Okay, and then that's how I'll get my quotient under the bar here, my remainder out of the box. All right, so like I said, we'll start with the 8.3 support questions, and they're going to have us find a quotient and remainder. Once we do them 3 problems, we'll go into the college algebra for 8.3, and we'll use it to find function values and to determine if a number is a 0. So y'all, let's get started on support examples. So for the support, we're going to use synthetic division to divide. So y'all, number 1, they're giving us. Now, when you're using it to divide, they'll keep them in parentheses. So we're going to have r to the third minus 10r squared plus 72r minus 22. We're going to take that and divide by r minus 6. Now, we got to check and see if there's any missing terms on this polynomial. So I'll start with my r3. I got my r squared. I got my r, and I got my constant term. So I got all the terms I need, so nothing's missing. So we're going to write down these coefficients first. A 1 for the r3, a negative 10 for the r squared, 72 for the r term, and then negative 22. So we wrote out our 4 coefficients. Now remember, leave a little space there and draw the bar. And then make sure under the last number, we square the bar, okay? Remember, that's going to be my remainder when I'm done. So I got my coefficients, drew my bar. Now we got to put our C over here. So this is where we'll put C. C will come from what we're dividing by. Now remember, since we're using it to find the quotient and remainder, and this is in factored form, our C is going to be a positive 6. Okay, so the C always has an opposite sign when it's in factored form like this. So bring that 6 over here, positive. So y'all, we're set up now. So now we're going to start doing our synthetic division. This first number, we bring down under the bar. And you're always going to bring that first number straight under the bar. Now we need to get the number in the second column here. So what we do, remember, we're going to take the number under the bar, 1, multiply by 6. So 1 times 6 will give me 6. And I place that into the next column. Now, we got 2 numbers in this column. You're going to add that together. So a negative 10 plus a 6 will give us a negative 4. Now, I got a number under the bar. So to get that next column, I'm going to take negative 4, multiply by 6, and get a negative 24. All right, now I got 2 numbers in the column. We're going to add that again. So 72 and a negative 24 will give us a positive 48. All right, y'all got a number under the bar. So this number now multiplies by the 6. to get the next column. So 48 times 6 gives me 288. And now, y'all, once I add this last column, I will have our remainder. So a negative 22, positive 288 gives us a 266. So that's my remainder. Now remember, I said these were the coefficients of the quotient. And it starts 1 degree less than this original polynomial. So since that's an r to the third, this will start as a r squared minus 4r plus 48. So you just bring them down in descending order. So I got 1r squared minus 4r plus 48, and my remainder equals 266. Okay, so y'all, that's the process. Bring them down, multiply, add, multiply, add. It's just a repeated process of multiplying and adding. All right, y'all, let's try another one. A 3b to the third plus 21b squared plus 28b minus 18. We'll divide that by b plus 5. All right, y'all, we're going to write our coefficients out, but let's see if anything's missing. So I got my b3 term, b squared term, b term, and my constant term. So once again, nothing's missing. So we'll write our coefficients: 3, 21, 28, and negative 18. Draw my bar. Box off the last part of it. So my C this time will come from this factor. Since the factor's positive, our C will be a negative 5. Okay, so notice it's always opposite than the factor. So bring over that negative 5. All right, y'all, here we go. Repeat the process. Bring the first number down under the bar. Now I'm just going to multiply and add, multiply and add. So 3 times negative 5 is a negative 15. 21 and negative 15 give me 6. 6 times negative 5 give us negative 30. 28 and negative 30 give me negative 2. And y'all, the last multiplying, negative 2 times negative 5 gives us a positive 10. So our remainder is negative 18 plus 10, which is what, a negative 8. So it's not a bad process once you get used to it, okay? So let's see what our answer is. It's 1 degree less than the original. So that's going to be a 3b squared plus 6b minus 2. And my remainder equals a negative 8. Now, y'all, our third one. Now, this third one, we're going to write the answer a little different than this one, okay? So on the third one, they write the remainder as part of the polynomial. And I'll show you how to do that. So let's see what we got here. I got an a to the third minus 8a squared plus 2 divided by a minus 3. All right, so remember the first thing we need to figure out if our coefficients are missing anything. So I got an a to the third term. I got my a squared term, and then it goes to the constant term. So we're missing the a term on this. So on this one, since we're missing the a term, we must use a 0 as a placeholder. Okay, so when I write my coefficients, I got a 1 for the a third, a -8 for the a squared, a 0 for the a term, and then a 2 for the constant term. So whatever's missing, you always got to put in a 0, okay? Now draw your box. In our C this time, well, since that's a -3, our C will be a +3. So y'all, we put in our 3. All right, y'all, so here we go. First step, we're going to bring down that 1. All right, then we're going to multiply this around, okay? So 1 times 3 is 3. -8 plus 3 is a -5. -5 times 3 is a -15. All right, 0 plus a -15 is -15. And then y'all finally, -15 times 3 is -45. 2 plus -45 gives us a -43. Now, y'all watch how this one, I write out this remainder, because they don't do the R equals on this one. On this one, we got our coefficients here. It's going to start 1 less than an a to the third. So that means that's 1a squared minus 5a minus 15. Now, the way they do the remainder on this, they do plus the remainder, which is -43, divided by, or it's over what we divided by, which was the a minus 3. So they put the remainder over this factor here, okay? Now, that's 2 ways to write our remainders. Up here, I could have did 3b squared plus 6b minus 2 plus this -8 over the b plus 5. So look at the answers. The first 2, because these are multiple choice. The first 2 are written like this, but that third one, they write the answer like this, okay?
So can you explain to us why number 3 is written like this and not like 1 or 2? Is it because it was missing that a term?
No, it's just because they're using different forms to write the answers. It's just the way MathLab did the questions.
Okay, so I was gonna say on MathLab, it'll change those questions.
Yeah, this one could have been wrote like this: minus 5a minus 15 r equals -43. They could have wrote it like that, but they just wrote the answer this way. This one could have been written like this. Any of them can be rewritten as each other. It's just the way the numbers were and the way that question was when MathLab made it.
Okay, so MathLab will just kind of change up how they want the answers to be given.
Yeah. And like I said, they'll be in multiple choice, so you'll be able to tell pretty quick.
Oh, okay.
Okay. All righty. So now that was the support. So we're going to get into the college algebra 8.3. So y'all, this 8.3 deals with polynomial division. And we're still only going to be dealing with synthetic division. But we're going to use it to find function values and to determine if a number is a zero. So here's the thing. To find function values, we use what we call the remainder theorem. And this remainder theorem tells us that the remainder from synthetic division is equal to the function value for that number being used. So just like when we was finding f of 4, f of -3, if I use those numbers as my c on these polynomials, those remainders I get in the box are actually equal to the function value, which would have been the same thing you'd have got if you'd have put that number in for all the x's and did your order of operations and all that fun stuff, okay? So it's another way to find function values. So let's see, there's about 2 or 3 doing that in this section. So we're going to use synthetic division to find the function values. So our number 1, they're giving us f of x equals x to the third minus 12x squared plus 41x minus 30. They want us to find 3 things: f of 1, f of a -5, and f of 6. So like 3 problems in one. Now remember, here's the thing. These are our C's. C will be 1, C will be -5, and C will be 6. When we're given them as function values, we do not change the signs of these numbers. We only change them when we do problems like we did in support, where they gave them to us as factors. So y'all, let's see if we're missing anything. I got my x3 term, my x squared term, my x term, and my number. So we're not missing any terms. So we'll write down our 1, -12, 41, and -30. I'm going to draw my bar. So on these problems, the remainder is the answer, okay? Now, the first one I'll do is f of 1. So I'm going to put a 1 into the box for my C. You know, what's nice, the synthetic division is the same as we did a while ago. All we're using is the remainder now versus all these other numbers, okay? Because we're not looking for the quotient and remainder, we're just looking for the function value. So y'all remember, the 1 we bring straight down. Now the 1's under the bar, we multiply by C. So 1 times 1 gives me 1. I'm then going to add that column. -12 and 1 give us a -11. All right, negative 11 times 1 is negative 11. All right, y'all, 41 added to a negative 11 is 30. 30 times 1 is 30. And y'all look at that. Negative 30 plus 30 gives me a remainder of 0. So that means f of 1 equals 0. So if you put a 1 in here, 1 to the third is 1. 1 squared is 1 times negative 12. So that'd give you negative 12. So we got 1 minus 12 so far, which is negative 11. Right here, 41 times 1 is 41. Negative 11 plus 41 is 30. And then that 30 minus 30 equals 0. So this synthetic division gives you the same answer as if you'd have put that 1 into that function. So y'all, let's hit this next one. It's a negative 5. So we bring down our C, which is negative 5. Our coefficients are the same. 1, negative 12, 41, and negative 30. All right, I'm going to draw my bar. So do y'all want to sort of lead me on this one? Anyone got this process down yet? Still early in the morning, huh? All right, y'all. So remember, bring the 1 down. All right, next I'm going to take the 1 times negative 5. That's going to give me negative 5. And really, the biggest mistakes you're going to get on these is doing the adding part. Like over here, you're adding these unlike signs. Well, here you're adding like signs. So like signs will stay negative. What's that? 12 and 5. So that's negative 17. All right, that negative 17 times negative 5 gives me the next column. So that's going to be 85. All right, let's see. Let's add that column. Let me see what my chat says. All right, so Hannah, we're about to see if you get a negative 660. If she's right, we'll make her guide us through the next one. How about that? So let's see. 41 and 85 gave me 126. 126 times negative 5 gave me negative 630. And y'all look at that. Negative 30, negative 630 give me negative 660. So f of negative 5 equals a negative 660. Yeah, that's cool, Hannah. All righty, y'all. All righty, y'all. So let's see. We got f of 6 left. All right, so my coefficients are staying the same. 1, negative 12, 41, and negative 30. All righty, y'all. So here we go. We bring that 1 down. 1 times 6 is 6. Negative 12 and 6 give me a negative 6. All right, negative 6 times 6 is a negative 36. So let me see what my chat's saying. Oh, I think I got you on one. So let's see. Because that 41 negative 36 gives me a 5. And here, 5 times 6 gives me a positive 30. So I think you got a sign off in here somewhere, Hannah. So let me see what you're saying now. So there you go. Fix it and got a 0. Yeah, that's
Yeah,
the thing. On
got a little.
these, y'all get moving too quick and you watch these signs, okay? So y'all, we got a 0 here. So f of 6 equals 0. So two of these, so if you put in that 6 in here, that's going to equal 0. Okay. So y'all, that's finding function values. So let's do one more of those and then we'll play with the 0 stuff. So this one has f of x equals. Oh, and this one's a little bit longer. Look at this. X to the 4 minus x to the 3rd minus 15x squared plus 31x minus 36. And they want us to find f of 5. And y'all watch these polynomials, they can make them as long as they want. So let's check if anything's missing. We got our x4, x3, x squared, x, and our constant term. So nothing's missing. So I'm going to write out all my numbers. So I got a 1, -1, -15, 31, and a -36. All right, I'm going to draw my bar. NRC. So let's see, we're finding f of 5. So C will be a 5. Now, y'all ready? Bring my 1 down. Multiply the 1 times 5. Next column, bring that 5. -1 and 5 give us a 4. 4 times 5 is 20. That goes in the next column. 20 and -15 give me a +5. All right, y'all. 5 times 5 is 25. So let's see. That's giving me what? 56. All right, 56 times 5. So let me see what my chant's going. I got 244, 244. So 2 y'all got 244. So let's see what y'all did here. 56 times 5 gave me what, 280? And y'all are perfect. I get 244. So y'all, f of 5 equals 244. So Charlotte, you and Hannah both got that one right. Good job. All right, y'all. So that's finding function values. Now we're going to use this synthetic division to determine if a number is a 0. So let's flip this over. So we're going to determine if a number is a 0. Here's the thing about that. If a number is a 0 of a polynomial, then the remainder must be 0. So if a number is a 0 of a polynomial, then the remainder must be 0. So remember, because that's what you would get if you actually set that polynomial equal to 0. So if these numbers are zeros of these polynomials, then that little remainder in the box has to be 0, okay? So that's what the rest of the college algebra wants us to do. And there's like 3 problems doing this. So using synthetic division, determine whether the numbers are zeros. Okay, so these start at number 3. So what they do, they're giving us 2 numbers. They're giving me -5, 2. So those are the 2 numbers they want me to check. And our polynomial is f of x equals 3x to the third plus 10x squared minus 19x plus 30. So I'll use these same numbers for both of these zeros we got here, or both of these potential zeros. All right, y'all, so I'm looking for any missing terms. So I got my x3, x squared, x, and my number. So nothing's missing. So I'm going to write down those coefficients: 3, 10, -19, and 30. So I'm going to draw my box. And we'll check -5 first. Now remember, these don't change signs either when we're checking for zeros, okay? So leave them the same sign. So y'all, let y'all spin that around a little bit and see if this is a 0 or not. So I'll let y'all work it because this gets y'all good at this. So y'all work that and y'all can chat me whether y'all think that thing is a 0 or not. That's either a yes or no question. Darla, that was quick. You got a yes on that? All right, so I'm about to see if you're right, okay? So we're going to bring our 3 down. So 3 times -5 is -15. 10 and -15 give me -5. -5 times -5 is 25. -19 and 25 give me what, a 6. And look at that, 6 times -5 is -30. And y'all, that 30 and that -30 give me a 0 remainder. So definitely yes on that -5. Oh, Timmy, okay, I see you got a 0 there. I was thinking, where the hell did you get a 9 at? But you're good. You got a 0. Good job. So y'all, that is definitely yes, because I got a 0 remainder. So now we're going to check 2. So our coefficients are the same: 3, 10, -19, and 30. All right, let's see what y'all saying on that one. So, so we're saying no for number 2. Okay, so let's roll that one through and see what we get. So we're going to bring our 3 down. 3 times 2 is 6. So my chat's lighting up now. Let me see what I get here. So I'm getting a bunch of no's. Okay, y'all. So let's see if y'all are right. So 10 and 6 is 16. Times 2 is 32. Minus 19 was 13. And y'all, 13 times 2 is what, 26? So y'all, let's see. I'm getting what, a 56 under here. So that's not a 0. So this one is definitely a no. Now, this one I think is the one when you answer this question, you'll have to pick yes because -5 equaled 0 for the remainder. And this one was no because it got 56 for the remainder, okay? So this one tells you to put in the numbers you actually got to verify why you got a yes and no on that. So y'all getting the hang of this. Apparently, y'all been knocking these out pretty good. All right, so we're going to check -1 and 1 this time. They're giving me h of x equals x to the 4th plus 2x to the 3rd plus 3x squared minus 5x minus 7. So let's see, x4, x3, x squared, x, and my constant term. So nothing's missing. So we'll start with -1. So we got a 1, 2, 3, -5, and a -7. All right, y'all. So play with that and tell me, is -1 a 0? So, woo, that was quick. So y'all getting good if y'all answering that quick. So I got a bunch of yeses coming on. So let's see if they are correct. So y'all bring down to 1. 1 times -1 was -1. 2 and -1 gave me a 1. 1 times -1 is -1. 3 and -1 is a 2. 2 times -1, -2. So I'm starting to agree with you because these are going to give me what, a -7. And that -7 times -1 is a +7. Added to the -7 gives me a 0. So -1 is definitely a yes. All right, y'all. So y'all got 1 now. So let's see. 1, 2, 3, -5, -7. So this one I've seen go yes, 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 no, no, yes. I've never seen it go no, no, but you never know. All right, woo, y'all are already going on there. So y'all are saying no for 1. So y'all, let's see if they're right on that one. So bring the 1 down. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 3 plus 3 is 6. 6 times 1 is 6. 6 and -5 gave me 1. And perfect, because 1 times 1 is 1. So it looks like I'm getting a remainder of a -6 for that one, which is definitely a no. All right, so y'all are getting good on these. So we got one more to do. So I tell you what, since y'all are getting so good on these, I'm going to up the ante just a little bit. So y'all, we're going to determine, is 1/2 a 0 of f of x equals x to the 3rd plus 1/2 x squared plus 5/2 x minus 3/2. So y'all getting so good. Well, this is the curveball. But even this one, you'll see it's not that bad because all the fractions they give you, they will at least have a common denominator. So that makes it a little bit better for us. So let's bring our C over here, which is a 1/2. And then let's see, we got our x3, x squared, x, and number terms, so nothing's missing. So I got a 1/2, 5/2, and then a -3/2. So I'm going to leave a little more space because I got fractions coming up. And then I'm going to leave my remainder there. So y'all watch this. We're still going to bring the 1 down. But y'all watch this. This ain't bad because 1 times 1/2 is a 1/2. Now y'all remember this. When you're adding these fractions, say 1/2 plus 1/2, the bottom will stay a 2 at this point. Everything gets done on top. So 1 plus 1 gives me 2. But y'all, 2 divided by 2 is just 1. So 1/2 plus 1/2 gave me a 1. All right. 1 times 1/2 is 1/2 again. So let's see, we're adding a 5/2 plus a 1/2. So remember, the bottom will be 2 at this point. On top, I got 5 plus 1, which is 6. But y'all look at that. 6 divided by 2 is 3. So my 5/2 plus 1/2 gave me 3. All right. 3 times 1/2 is 3/2. So remember, when you multiply, you treat the 3 like it's over a 1, and you just multiply straight across. Top times top was a 3, bottom times bottom was a 2. So that gave me a positive 3/2. And look at that, negative 3/2 plus 3/2 gave me a 0, which means that was a yes. Now, I'm going to let y'all play with a fraction 1. So y'all let me let y'all write that real quick. And then I'll give y'all one and see what y'all do with it. Okay, y'all, so let me see what I'm going to hit y'all with. Y'all try this one here. So they want to know, once again, is 1/2 a 0 of f of x equals x to the third plus 5/2 x squared plus 9/2 x plus 9/2. So y'all spin that one and see if this 1/2 is a 0 of that polynomial. And I'll be writing my stuff down. So I got a 1/2 there. Let's see, I got what, a 1, 5/2, 9/2, and 9/2. All right, so y'all, I'm looking for what, a yes or no on that one. So this is y'all's curveball. And there's only one they do to you like this. This is y'all's number 5 on the homework. Little trickier with them fractions though, right? All right, so I'm starting to get some answers in, and y'all are saying no on this one. All righty, so let's check that out. So I'm getting 2 no's. So let's see what y'all did. We brought the 1 down. 1 times 1/2 was 1/2. So 5 halves and 1/2 gave me 6 halves, which gave me 3. 3 times 1/2 is 3 halves. Ooh, y'all got some good numbers here. Let's see. 9 and 3, that gives me 12 halves, which is 6. 6 times 1/2 is 6 halves. Oh, y'all, I know that's not going to cancel, but if I was to add those, I'd get what, 15 over 2? So 15 over 2 won't reduce. But y'all, good job. So y'all did get that 15 halves. Good job. So that is definitely a no. So I guess my curveball didn't have enough break on it, did it? Yo, so that is the 8.3 college algebra. So all I'm going to do now, we're going to play with the 8.4 support. So that this will get you ready for the 8.4 college algebra. And y'all, these examples mainly, the first, oh, let me see, there's like 7 of these, I think. Let me see. There's 7 altogether. The first 6 deal with multiplying. So we're going to multiply for the first 6. But y'all, these are some tricky things to multiply. Like this first one, I got W plus R times W squared minus WR plus R squared. So they're getting you ready to foil this kind of stuff when you got 2 things times 3, okay? So we're going to foil this, but basically we're going to take the W, multiply by everything in the second parentheses. Then we'll come get the R, multiply by everything in the second parentheses. So these 2 things times these 3 things is going to give us 6 things going across here, okay? Now, the W times the W squared gives me a W to the 3rd. This W times that negative WR is a negative W squared R. So basically, I'm just adding a R to everybody. I mean, a W to everybody. And then that W times that R squared is a positive WR squared. So I had 2 W's, I now got 3. I had 1 W in an R, I now got 2 W's in an R. I had an R squared, I now have a WR squared. That's what happened multiplying through that W. Now we multiply through with the R, and we're just going to add an R to everybody. So the R times W squared is a RW squared. The R times a negative WR is a negative WR squared. And then finally, the R times R squared is a positive R to the third. Now, y'all, I didn't alphabetize this stuff, but I will tell you, you got two sets of like terms down here. The like terms will have the same variables and the same exponents on those variables. So this W2, this W squared R is the same thing as the RW squared. We just don't have this one in alphabetical order. So what happens when you add this negative W squared R to that positive RW squared? Well, -1, +1, those two things are going to cancel. Now, the WR squared and this negative WR squared, those are like terms. And one's positive, one's negative. So guess what? Those cancel. So remember, although some of these are out of order, they're still like terms because the W still has an exponent of 2, and then the R has an exponent of 1. So all this stuff in the middle canceled. So y'all, all that's left is this W3 plus this R to the third. Okay, y'all, so we're just getting you ready for this kind of foiling that's coming up. And y'all look at this one. Ooh, this one's got a R minus G times R plus G times R squared minus G squared. So 4 things. So I'm going to tell you what I would do to this. I would start with this stuff right here. Because y'all, these 2 things right here that I'm about to foil, these are called conjugate pairs. R minus G, R plus G. Conjugate pairs always look the same other than the sign on them, okay? One will be subtracted, one will be added. So on the side, I'm going to foil that real quick. Now, the reason I want to start with these, because conjugate pairs, when you foil them, the 2 middle terms will always cancel out 100% of the time. So y'all watch this. R times R is R squared. R times G is RG. Negative G times R is a negative GR. And then that negative G times G is a negative G squared. But y'all, RG, negative RG, because remember, I don't have them in alphabetical order, but these are like terms, but they cancel. So I end up with an R squared minus a G squared. So I'm going to replace this with that. So that gave me an R squared minus G squared times this one, which is a R squared minus G squared. Now, y'all don't get fooled on this one. These ones are not conjugate pairs because they're both being subtracted. Now, since they're both being subtracted, my middle terms are not going to cancel on this one, okay? All right, y'all, so watch this. R squared times R squared. 2 plus 2 gives me an R to the 4th. R squared times a negative g squared is a negative r squared g squared. But you will notice when you're multiplying the same thing times itself, the two middle terms will be the same. So watch this. A negative g squared times r squared is a negative g squared r squared. And then at the end, that negative g squared times a negative g squared is a positive g to the fourth. So notice the like terms are both negative. So they're basically going to double. So bring down this r to the fourth. You have a -1 and -1. That gives you a -2 r squared g squared. And at the end is our positive g4. Okay, so remember, like terms can be like, although they're not in alphabetical order. But the variables have to have the same exponents, okay? So y'all are going to make you do this kind of foiling because in 8.4, we're going to do a lot of this kind of foiling, okay, for the college algebra. All right, so now let's play with some imaginary numbers. Now, this one has a -4i times -4 plus 3i. Now, y'all, here's the thing about this. If we get an I squared, so I squared, if we get an I squared, we got to replace it with a -1. Okay, so I'm going to go to the calculator real quick. So let me share my screen with the calculator here. And I'm going to prove that. So you see the I down here above the decimal? It's blue. So if you'll hit the blue button and then the decimal, you get the I. And I'm going to square that. So there's my I squared. And y'all, when I hit enter, look what it gives me. Whoops, hang on. Let me get my, it gave me -1 plus 0i, which is basically -1. Let me see. My mode must be set on real stuff. Okay. Now let me show you the old calculator. So I'm gonna switch it over. So second decimal to get my I, then I'm gonna square it, and I'm gonna hit enter. So notice the older calculators just give you the -1. That newer CE, it'll give you -1 plus 0i. But remember, 0 times I is just 0. They're just giving it to you in that A plus BI form. But all we need is to know is that I squared equals -1, okay? So that means I can't leave an I squared part of my answer. I got to turn the I squared into -1 and then finish out the problem. Now, these answers have to be in this form, A plus BI. I'll get my real number and then my imaginary. So y'all watch this. A -4i times -4 is a positive 16i. That -4i times 3i is a -12i squared. Hey, also think about this. I don't have like terms, so these won't add together. So the next step would be to replace that I squared with a -1. So that's going to give you 16i minus 12 times -1. All right, bring down that 16i. So what's happening here? You got a -12 times that -1, well, y'all, that's going to make that 12 positive. So all I squared does in the long run is change the sign of the number in front of it. If the number in front of I squared was negative, it's going to become positive. Now, I'm pretty close to the end, but I need to put it in A plus BI form. So in MATLAB, you're going to write 12 plus 16i. Now, do y'all remember a while ago on that calculator, I showed you where the I was? So these imaginary numbers and these complex numbers, we call them. Watch this. I'm about to put it on the calculator. So let me find my calculator. So I had a -4i. So -4, second decimal to get the I. Parentheses, -4 plus 3i, which will be second decimal, close parentheses. So we got 12 plus 16i. So y'all watch when I hit enter. 12 plus 16i. So that calculator will do all these problems with these imaginary numbers, okay? All right, y'all watch this. 4 has 8 plus 2i times 3 minus 6i. Now, this could be done on the calculator, but I'm actually going to do this by hand to show y'all how you would actually do this. But we're going to FOIL it just like we do if these were x's. So 8 times 3 is 24. A times -6i is a -48i. 2i times 3 is a positive 6i. And then y'all, 2y times -6i is a -12i squared. So on this one, we realize we got like terms in the middle here. So I'm going to bring down my 24. So the -48 and the positive 6 give me -42i. Minus 12. And guess what? We're going to turn this I squared into a -1. So I'm going to work that now. So I got my 24 minus my 42i. Well, look at that. This -12 times that -1 makes that a positive 12. Oh, and y'all guess what now? I've still got like terms now. Since I turned them I squareds into that -1, that made this a number that'll add to the 24. So the 24 plus 12 now give me 36 minus my 42y. So once you convert that I squared into a -1, you're now getting a single number that will add to that number in the front. All right, y'all. Let's do conjugate pairs. 2 plus 6i, 2 minus 6i. Now, these are conjugate pairs. Remember, they're exactly the same other than the adding and subtracting. So when you multiply conjugate pairs of imaginary numbers, you're going to end up with a single real number. The I stuff goes away when you got conjugate pairs, okay? So the I's will go away. So y'all watch this. 2 times 2 is 4. 2 times -6i is a -12i. 6i times 2 is a positive 12i. And then 6i times negative 6i is a negative 36i squared. So do y'all see this right here in the middle? Negative 12i, positive 12i, they cancel. Anytime we do conjugate pairs, those middles will always cancel. So I bring down that 4. Now, we're turning the I squared into a negative 1, remember? And all that negative 1 is going to do is change that negative 36 into a positive 36. So you can do 2 steps at once. Right here, I just wanted to show you each step to show you really what's happening with that. But right here, I'm going to treat the I squared like a negative 1, and a negative times negative made that a positive. And now my like terms, 4 plus 36 gives me a final answer of 40. So that's one of the properties about conjugate pairs, is that the I goes away. Okay? All right, y'all. 9 plus 7i times 9 minus 7i. Now, y'all, I'm going to show you a trick that you can always do with conjugate pairs, because these middle terms are always going to cancel. So when you got conjugate pairs, we can do what I call shortcut FOIL. But this only works when they're like this, conjugate pairs. Everything's got to match up except for the adding and subtracting. But if we notice we got conjugate pairs, we can multiply the first 2 terms together. So 9 times 9 is 81. Then we multiply the last 2 terms together. So 7i times negative 7i gives me a negative 49i squared. Okay, because this 9 times negative 7, 7 times 9, that stuff is going to cancel anyway. So this is called the shortcut FOIL. First times first, last times last. Okay, so I did first times first, and then I did last times last. All right, remember that I squared equals negative 1. So this basically becomes an 81 plus 49. I squared's only purpose in life is to change the sign of the number in front of it. And y'all, 81 and 49 give us 130. But y'all, like I said, let's go to the calculator. It knocks those out quick. Let me clear everything. So that one I had parentheses. 9 plus 7i. So 9 plus 7. Second decimal to get my I. Close parentheses. Open parentheses. 9 minus 7i. Second decimal. Close parentheses. So watch that. We should get 130. There you go. All righty, y'all. So the last problem here. So let me see if I got enough. So let me bring out one more page. So for number 7 here. Well, we're not multiplying on this one. We're actually going to solve an equation. And we're going to solve x squared plus x. Whoops, let me start that over. My bad. It's a x squared minus x plus 2 equals 0. And y'all, this one we got to solve using the quadratic formula. So we got to get more practice on the quad formula because we're going to use that in this section 8.4. So remember, the quad formula is x equals negative b plus or minus square root b squared minus 4 times a times c, all divided by 2 over a. So when these trinomials do not factor, we got to use the quadratic formula. And the reason I knew this didn't factor, because I would have to find factors of 2 that add to get 1. Well, factors of 2 subtract to get 1, but they don't add to get that 1. So this does not factor, so we got to use the quad. So y'all just get more practice. So A is 1, B is negative 1, and C is 2. So we're going to plug them in and work this, okay? So I got x equals negative b, which is negative 1, plus or minus b squared, which will be negative 1 squared, minus 4 times a, which is 1, c, which is 2. All of that over 2 times my a, which is 1. So you plug all that in. Now, double negative makes that a positive 1, plus or minus. Under this radical, negative 1 squared is a positive 1. Now remember, everything over here is being multiplied. So negative 4 times 1 is negative 4. Negative 4 times 2 makes that a negative 8. All over 2 times 1, which is 2. All right, y'all. So we're continuing on because we got to play with the radical part now. So I got 1 plus or minus square root. 1 minus 8 gives us a negative 7. All of that over 2. So on the side here, because the next step, we got to try to simplify this radical. I got a square root of negative 7. So now it's been a few weeks since we played with this quadratic formula. But y'all, can I do anything to this radical? Now, I can't do anything about that 7, right? Because it don't have none of them perfect squares as a factor. But do y'all remember what I got to do about that negative? Because I cannot leave that negative under that radical. So what do these negatives come out as?
Didn't we have to make it an I?
Perfect. We made it an I. So that anytime we had a square root of negative 7, that basically is going to give me what, an I square root of 7. So let me see what my chat says. So it makes it a yeah, but remember the 7's got to stay under the radical, y'all, okay? Because we couldn't bring the 7 out, but we did bring the negative out as the I. So good job, y'all. So this becomes a 1 plus or minus I square root of 7 all over 2. Now, if this wasn't an I here and it was a radical, we'd be done. But since we got the I in this answer, we got to write it in the A plus BI form. That means we got to split this into 2 fractions. So you take the 1 and put it over the 2. That's the real part. And then you got your plus or minus. And then the imaginary part will be the I square root of 7 over 2. So remember, MathLab's a little picky about the imaginary stuff. Now, you could write it like that, or you could do it as a 1/2 plus or minus square root of 7/2, and then put your I. It will take it either way right here, okay? But the thing about it, anytime you got I's in the answer, MATLAB wants them split apart as a real fraction and then a imaginary, okay? All right, so it looked like a support day more than anything today because we did the support 8.3 and support 8.4. And then the college algebra part was just the 8.3 where we found function values and we found whether numbers were zeros or not. So y'all, let me stop that share. And I'm gonna stop my video so that I can get that sent to y'all later.